In this video, let's talk about callbacks from C into Java using JNI. Normally, JNI is used when Java calls a native function written in C or C++. But sometimes you want the reverse, you want your native code to call back into Java. This is called a JNI callback. So why would you ever need to do this? The incentive is pretty strong. Callbacks are useful when you have a native library doing heavy work and you want to notify Java when it's done. They're also common in event-driven programming. For example, a C library might trigger an event when data arrives on a socket, or when a long calculation finishes. Instead of Java constantly polling for results, the native code can push the result back to Java through a callback. This allows you to combine high performance in C with flexible business logic in Java. Now, how does this work internally? First, any native thread that wants to call into Java must attach itself to the JVM. You do this with AttachCurrentThread, which gives you a JNI env pointer for that thread. Then you find the Java class or object, look up the method ID, and call the Java method using CallVoidMethod or CallStaticMethod. Once the work is done, you should detach the thread from the JVM with AttachCurrentThread. Sounds simple, but here's the danger. Callbacks are tricky and can easily crash your JVM if you make mistakes. One danger is thread attachment errors. If you call into Java from a thread that hasn't been attached, the JNI env pointer is invalid and you'll get a hard crash. Another danger is reference misuse. If you pass a local reference from one thread to another, or forget to promote it to a global reference, the garbage collector might clean it up and you'll be calling into thin air. Deadlocks are another risk. If your callback grabs a lock that's already held by Java code that's waiting on your native code, the system can deadlock. Exceptions also need care. If a Java method you call throws an exception and you don't check it with exception check, that exception remains pending and will break future JNI calls. Finally, performance is a danger too. If your native code calls back into Java in a tight loop, the overhead can be massive. It's always better to batch work and reduce the number of callbacks. So in summary, the incentive for callbacks is that they let native code notify Java, making your system event-driven and efficient. But the danger is real: crashes, memory leaks, deadlocks, and performance bottlenecks if you're not careful. The rule of thumb is to use callbacks sparingly, always attach and detach threads correctly, manage references safely, and handle exceptions properly.